So hello again everyone. Today we will be talking about a few common oxidizing agents that are used in organic chemistry. So these are also used in laboratory organic chemistry and also while we are practicing organic reactions. So the first one is a name reagent which is known as the Jones reagent. So this is the chromic acid H2CrO4 which is actually used as a Jones reagent. Solvents are generally aqueous H2SO4 and acetone, and acid sensitive systems should be avoided because this is acidic. Okay, so let us see which functional groups is actually oxidized using this Jones reagent. So the Jones reagent is quite a broad spectrum oxidizing agent. It can oxidize 1 degree alcohols to carboxylic acids, aldehydes to carboxylic acids, and also Jones reagent can oxidize 2 degree alcohols to ketones. Hence we can see that it can oxidize alcohols to the carbonyl compounds as well, because 2 degree alcohols can be oxidized to ketones. Amines and sulfides of such functionalities should be avoided while using with this reagent, because generally they can cause reactions which can produce like cyanides or nitriles, and also sulfides can produce hydrogen sulfide, so it can be poisonous. And in the workup, excess reagents should be destroyed, and the products could be extracted via the solvent extraction method, organic solvent extraction method. Okay, so let's go to the second reagent that we have here. It is known as the Collins reagent. It is also a name reagent. So the Collins reagent is basically CrO3 chromium trioxide with 2 molecules of pyridine. This is also written as CrO3 dot 2 pyridine 2py. So let us see the solvents that is generally used this reagent. So it is methylene chloride is used, CH2Cl2, which we also know commonly as dimethyl chloride. So dichloromethane, so which is called the DCM. And DCM is a very common lab solvent that we use. It is heavier than most of the organic liquids and also heavier than water. So it oxidizes 1 degree alcohols to aldehydes, 2 degree alcohols to ketones, and also like the workup procedure is quite easy in this case, because we can just filter out the inorganic salts, and then after washing with aqueous acid we just need to remove the DCM, the CH2Cl2, and we will get our product. Okay, so going to the third oxidizing agent we have here is pyridinium chlorochromate. So this is also known as PCC. So this is also an oxidizing agent which is used in the solvent DCM, which is dichloromethane. So here also the solvent is used as CH2Cl2. The formula obviously of PCC is CrO3Cl dot pyridine. So this is also can be written as CrO3Cl minus and pyridine NH plus. So pyridine is protonated in this case. The solvents that are used is DCM, CH2Cl2, as I said. And let us see the groups that it can oxidize. Actually PCC and the previous reagent that we saw, which is the Collins reagent, are almost similar. So PCC also oxidizes 1 degree alcohols to aldehydes and 2 degree alcohols to ketones. The workup procedure is also same. We have to filter out the inorganic salts, that is the inorganic, especially the chromium salts that are forming, and after that we have to wash it with aqueous acid, and then we can remove the DCM to obtain our product. Okay, so going forward with the fourth oxidizing agent that we have here, which is known as the dimethyl sulfoxide, and another constituent is there. So let us first see the formula of dimethyl sulfoxide. So this is how we can write it, and along with this we have to use here DCC, which is dicyclocarboxyl diamide, or acidic anhydride Ac2O, or CF3CO whole twice O, which is known as the triflate anhydride, or SO3 or phosgene COCl2 can also be used. So we need to use a dehydrating agent with DMSO in this case. So as you can see, DCC, Ac2O, anhydrides, all are like dehydrating agents. Now the solvent that is used here is CH2Cl2, which is DCM, or ethers, or DMSO itself can also be used as solvent. So this is actually a milder reaction than the previous two. So here also the oxidation that happens is of 1 degree alcohols to aldehydes and 2 degree alcohols to ketones. The workup procedure is that first we have to neutralize the reactants, and after the neutralization of the reactants happens, we can remove the solvents to obtain the products. Okay, so the fifth oxidizing agent we have here is potassium permanganate, so KMnO4. This is also a quite well known oxidizing agent which can actually oxidize a lot of functional groups. The first we see the solvent, which is water and organic solvent mixture. This particular oxidizing reagent actually oxidizes aldehydes to carboxylic acids, 2-degree alcohols to ketones, alkenes to vicinal diols. So both of the alkene carbons would have OH group in front of them. Alkynes to carboxylic acids, corresponding carboxylic acids, and also in this reaction amines or sulfides should be avoided while using this reagent. And the method of workup is to destroy the excess reagent, the unreacted part that is present, and after that we can extract the product using the organic solvent extraction method via phase separation. Okay, so let us go forward with the next reagent. So here we have osmium tetroxide, OSO4. So this osmium tetroxide OSO4 reagent is used in pyridine as solvent, and often the pyridine is also used catalytically for helping in the reaction. Okay, so let us see what type of functional group this can oxidize. So it basically oxidizes alkenes to vicinal diols. So this is the only oxidizing thing that it does. So it basically forms diols from alkenes. And workup is that you should destroy the excess reagent, and after that the product is extracted via phase separation or the solvent extraction method. Okay, so going forward to the seventh oxidizing agent we have here is known as the periodic acid, HiO4, and the solvent is water or aqueous mixture. So this is actually used in aqueous solvent. After that we can see the the reagent that it oxidizes. So it basically oxidizes the vicinal glycols. So if there are two OHs in 2C, it oxidizes it to carbonyl compounds. So if there is like COH bond COH, it will form C double bond O bond C double bond O. Workup is basically the destruction of the excess reagent, and after that the product can be extracted using solvent extraction method. The eighth oxidizing agent that we have here is known as the lead tetraacetate, which is also can be written as CH3CO whole 4 Pb or PbCH3CO whole 4, whatever you say. The connection of lead is with the O of CH3CO, that's all. The solvent that is used in this reagent is benzene or acetic acid, and the oxidizing functionalities are it can oxidize vicinal glycols to carbonyl compounds, as we saw in the previous reagent. So this function is also the same. So the previous reagent was osmium tetroxide and periodic acid and lead tetraacetate have got similar functions. Workup is also same. Okay, so going forward to the ninth oxidizing agent that we have here are peracids. So it can be acetic peracid, it can be benzoic peracid, and CH3CO3H or C6H5CO3H. Solvents are DCM, CH2Cl2, or ethers can also be used as solvents, and it can oxidize alkenes into epoxides, ketones to esters, and also in this case amines and sulfides should be avoided with this reaction. So alkenes are oxidized to epoxides and ketones are oxidized to esters using peracids. Workup is to destroy the excess peracid, excess reagent, and then the products are extracted using solvent extraction or phase separation method. Okay, so the last oxidizing agent that we have as a common oxidizing agent used in organic chemistry is ozone, O3. The solvent is DCM, or sometimes alcohols can be used. Chloroform can also be used, CaCl3, and sometimes alcohols can be used. Okay, so let us see what ozone can do. So ozone does ozonolysis, that is, it actually cleaves the alkene and alkynes, the unsaturated double bonds, to carbonyl compounds via the Moll ozonide process. So ozonolysis process can also be seen. The mechanism should be checked. The workup is destroying the excess ozone that is present, excess reagent, and then the products are extracted using solvent extraction method. So thank you for listening to this video, and follow and subscribe for more such videos. I'll be coming up with organic reactions in the next videos, and also now I'll be delving into physical and inorganic too. And as I always say, practice and write organic chemistry reactions as much as you can write. Be enthusiastic about it, and you will be good in no time. Okay.